Section 4.4 is all about L'Hopital's rule, and so L'Hopital's rule allows us, if we have a limit and we evaluate it and it comes to 0 over 0, it doesn't exist, it's infinity over infinity, negative infinity over infinity, negative infinity, then we can take the derivative of the numerator and denominator separately, not the quotient rule. We can take the derivative of the numerator and then take the derivative of the denominator and then reevaluate it to see if we get an answer. So our first example is the limit as x approaches pi over 2 from the right, and then it's cosine of x all over 1 minus sine of x. So when we evaluate this, we get 0 over 0. So then we can take the derivative. So we take the derivative, we have the limit as x approaches pi over 2 from the right, and it's negative sine of x all over 1 minus sine of x is, so 1 minus sine of x is negative cosine x. And then we can simplify this, so it's limit as x approaches pi over 2 from the right, and this we get tangent x. And we evaluate this, so the limit as x approaches pi over 2 from the right, we end up getting negative infinity. So that's our limit. Then for our second example, we have the limit as x approaches 0 of the radical 1 plus 8x minus radical 1 minus 2x all over x. So again, we don't use the quotient rule. We take the derivative of the numerator and denominator separately. So we're going to rewrite this so it's easier to take the derivative. So we have limit as x approaches 0. So we're going to do 1 plus 8x to the 1 half minus 1 minus 2x to the 1 half all over x. So when we take the derivative of this, we get the limit as x approaches 0. So we have to use a chain rule, so it's 1 half times the quantity 1 plus 8x, and then we have times 8, then we have minus 1 half, leave 1 minus 2x, and then take the derivative of 1 minus 2x, which is minus 2. And we put it all over 1, because the derivative of x is just 1. So then we can further simplify this. I forgot. This is still, so then this is negative 1 half, and this is negative 1 half. So then we can go on to rewrite this. So it's the limit as x approaches 0. We have 4, because we have our 8 times 1 half, so we get 4. And then, since this is a negative exponent, we can move it to the bottom. So we have 4 over rad 1 plus 8x. And we also have plus, because we have our negative 2 times negative, so that's positive. And then the 2 and then times 1 half is just 1. So we have plus 1 all over, again, we can bring this to the denominator, rad 1 minus 2x. And when we evaluate this, we have 4 over, and then 8 times 0 is 0 plus 1 is 1. Rad 1 plus 1. Similarly, we just have rad 1. So it's 4, because rad 1 is just 1, and 4 over 1 is 1. So similarly, 4 plus 1, and then we have our limit is 5.